Hey guys, let's solve this reversing linked list problem. Okay. Oh, wait a minute. In this problem, what we need to do is we got any linked list. We got a linked list like this. We need to reverse it. So that means our last node pointed to the previous, like that. Okay. This kind of all of nodes want to point back to its previous. And what will be the first value pointed to? Let's take a look at what is the next node of this one. It would be null, so our first node also need to point it to null, right? Okay, so this is the problem we need to solve. So let's find out how we can solve this. Okay, so simply let me say I am at this index. Okay, I need to point this value into its previous. So what I need its previous value. Okay, I need the previous value of that node. So what is that? That is 1. Okay, for now that is 1. Okay, now but there comes a problem. If I right away point that into the previous one, then my next node will be replaced. That means this will no longer have a connection. Okay, in that case we can go forward in the list, so we need to keep track of the next also. Okay, so let's track the next. What is in its next 3? So we will keep track of the next. Okay, we got both. Now what we need to do? We need to assign it into this way. Okay, we assigned. After then we need to go we need to go or move our pointer into next node. In this case we need our previous as this one, but we haven't updated that. So when we are going from this, we need to update our previous also. So let's do that. Okay, after then we will go to the next value, that means 3. Okay, okay, now in the tree, now we are at 3. What is the next value? It is 4. Okay, I set that. Then I point it in back to my previous. Okay, then set my current node as this one, the previous. Then I go to the next node, that means this node. Okay, then what I did I set my next node as 5, that means this node. Okay, then point my current node back to its previous, this node. Then set current node as previous, then go to this next, that means here. Now what I did, take the next value, assign the next value right there, that means null. What is null? Next value null, point it into its previous, yeah, previous. Then go on. Okay, then set the previous as my current as previous, that means 5. Then go to the next value. Then what is the next value? It is null. Now I am pointing at here, so you can see it. Now I am pointing at here. Now in this case we just return the previous. Now take a look. When the null occurs, our node becomes the first node of the result. Look at this, come here. Okay, so at that case we just return our previous value. Okay, so you guys got it. So now let's see how this will be seen in code. Okay, now let's see. In the first case, what we need to do, we need to create a previous node. So initially we set the previous node as null because initially we are going at this node. Okay, then what we need to do, we need to loop until the node becomes null, right? At this point we need to stop. That's the thing we just done here, right? Then what we need to do, we need to keep track of the next value. The previous value is already taken here, then we track the next value right here. Okay, we set the right value, next value as the next of the current. Okay, now then we need to set the these values next into the previous one. That means in this case null, so we set that into null. Okay, that's kind of cool. Then what we are going to do, we will set our previous int as our current. Okay, that's cool. That means, okay, that's cool. Okay, then we will set our current as the next value. Yeah, that's also cool. Then in the next iteration we will be at the next index, and similar then we will do all kind of things like that. Okay, then at last we will just return our previous value. That's the only thing we need to do. Then this is the solution. Okay, and what would be the complexity of this solution? Just simply take a look. We need to go to every node here. Okay, we are visiting every node. That means our time is of, oh sorry, time is of n, right? Okay, then what about the space? Does we taking any extra space here? We are taking a space for this one, and each level we are taking this, but in Java this is collected by garbage collector or garbage, so don't worry about that. We are not taking any extra space because constant are ignored in space and time complexities, so we are not taking any extra space. That means of 1. Yeah, this is our solution. So thank you.